Welcome, my students. Now we have established the relation F equal to ma, force equal to mass into acceleration. After completion of this, we will go through the Newton's third law of motion. Now, from this relation F equal to ma, we will obtain the units of force. In CGS system, unit of mass is gram and unit of acceleration is centimeter per second square. So 1 gram into 1 centimeter per second square, that is equal to 1 dyne. So 1 dyne force can be defined as the quantity of force acting on a body of mass 1 gram can generate an acceleration 1 centimeter per second square. That is 1 dyne. In SI, M means mass means 1 kg into acceleration means 1 meter per second square. That is equal to 1 Newton. So 1 Newton force is defined as the quantity of force acting on a body of mass 1 kg can generate an acceleration 1 meter per second square. Notice that the word Newton is started with small n. Any unit should be started with small letter. If its abbreviated form is written, then the unit named after a person will be in capital. 1n we can write. This is Newton. So we have obtained the CGS unit of force and SI unit of force, and the relation between 1 Newton and 1 dyne is that 1 Newton equal to 1 kg into 1 meter per second square. That is equal to 1 kg means 1000 gram, 10 to the power 3 gram, and 1 meter per second square 100 centimeter per second square, 10 square centimeter per second square, 10 to the power 3 into 10 to the power 2, that is 10 to the power 5 gram into centimeter per second square, that is dyne. So 1 Newton equal to 10 to the power 5 dyne. 1 Newton equal to 10 to the power 5 dyne. And from this relation F equal to ma, we will be able to solve the numericals regarding force. Now this is second law of motion. Now we will start third law of motion. Initially, we have shown that in the third law of motion, it has been stated that to every action there is same or equal and opposite reaction. Its statement is very easy. To every action there is same and opposite reaction. So if we apply force, that force will be action, and to every action there is opposite reaction. If we strike on a wall, say there is a wall. If we strike on the wall, it is a wall. If we strike on the wall, then a force is applied on the wall. This force is action force, and according to Newton's third law of motion, to every action there is same and opposite reaction. Same and opposite reaction will be applied by the wall on the hand, and therefore the hand feels pain. So this is an example of action and reaction. Keep in mind that action and reaction takes place on two different bodies. That is not on a single body. If two opposite and same forces, two forces having same magnitude, two forces F1 and F2 having same magnitude act on a single point on the opposite direction. Say this force F1 is acting on the point in this direction and F2 acting on the point. This point is P. and the opposite direction. Then equilibrium is established. Equilibrium is established. Say you are pushing a person in a swing from the backside, and with the same force, your friend is pushing the person from the opposite side. Then the person will not move in the swing. This is the state of equilibrium. So equilibrium is established when two same force. If it is F1, then it will also be F1, same magnitude. So it will also be F1. We can give its name F2, but it will be F1 in magnitude. So this is F1 and this is F1. Two same force reacting on the same point or same body in the opposite direction, then equilibrium is established. So in the third law, it can be stated that to every action there is same and opposite reaction. So action and reaction generate equilibrium? It's a question. Generate equilibrium? No. Action and reaction, though the two different forces equal in magnitude and in opposite direction, but they cannot produce equilibrium. No. What is the reason behind this? That in spite of having same force and opposite force, action and reaction cannot establish equilibrium. The reason behind this is that initially we have stated that if two forces having same magnitude act on the same point in the opposite direction, this is one direction, this is one direction, opposite direction, then equilibrium is established. But in case of action and reaction, though they are same and opposite, but they cannot produce equilibrium because they act on two different bodies. That is on two different points. This is the keyword. For establishment of equilibrium, two opposite and equal forces should be acted on a single point or single body, but here it act on two different bodies, so equilibrium will not be established. Now in the next class we will go through the numericals from F equal to A. Thank you, my students. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.